Today we're doing lesson 8.8 on the difference of squares, which they're talking about when a number is a perfect square. So perfect square examples could be 81, which would be the square root of 9. The square root of 81 would be 9. So that would be 1. Any number times itself really would be a perfect square. So here's an example of what you would do with a perfect square. Notice that there's a minus sign, and that's the only way that you can factor when you have perfect squares, because if it's a plus sign, the middle terms would not cancel themselves out when you separated it into factorable form. So we're going to do lots of examples like this. So here's our first one. We have 81, which is a perfect square, because we can take the square root and it's an integer. So 81 and the square root of 81 would be 9. And then you can split it up into c and negative c, and that will give you the two terms. So if we split it up, we would have 9 minus c and 9 plus c, and that would be our factorable answer. Then we go to the next one. 64 is also a perfect square, which we could split up into 8, and both of the variables have squares with them, so we can split them up as well. So we could do 8g minus h and 8g plus h. Here's a few more examples. This one, they both have perfect squares. You have a 9 and a 4. But they have an x in common, so we're going to take the x out first, because if you can factor anything out before you do this process, that's what you want to do. So it's 9x squared minus 4. And then we're going to focus on factoring the parentheses more, because you can see there's perfect squares. So we're going to split it up into 3x minus 2 by just taking the square root of both, and 3x plus 2. And then that would be our factorable answer. The next one, we can take out a negative y. So that's going to give us 4y squared minus, whoops. And the reason why I took out a negative y is because I wanted to make the second term minus so that I can keep factoring it. So minus 9y, or just 9. And then we're going to look at the parentheses more, and since both are perfect squares, we can keep going. So we're going to split it up into 2y minus 3 and 2y plus 3. And once you get it down to no more perfect squares, you know that you've factored it all. Here we have y to the 4th minus 1, so we're going to have to split this up into perfect squares. So y squared minus 1 and y squared plus 1. Now, since y squared minus 1 is technically a perfect square, we can split this up even further into y minus 1 and y plus 1. And then the y squared plus 1 parentheses has to stay like it is, because we have a plus 1, like I said in the beginning of the lesson, and plus 1 will not give you something that cancels itself out like the first two parentheses. So this is as much as we can factor it. Okay, the next one is 4a to the 4th minus b to the 4th. So we're going to split it up again into perfect squares. So 2a squared minus b squared and 2a squared plus b squared. And since we don't have any more perfect squares, that's as much as we can do. The next one, also we're focusing on perfect squares here, so 81 is a perfect square. Since it's x to the 4th, each x term is going to have x squared with it. So we have 9 minus x squared 9 plus x squared. And then since 9 is a perfect square and we have a minus x squared, we can split that up into even further. 3 minus x, 3 plus x. And then we have to keep the other one how it is because we have a plus sign instead of a minus sign. Next one, we can also do the same thing. We have 4y squared minus 1 and 4y squared plus 1. Since 1 is also a perfect square, we have 4 and 1 in the first term here, or the first parentheses, that we can take the square root of. So we can do 2y minus 1 and 2y plus 1. And then the second set of parentheses has to stay as it is because of the plus sign. Next one, we can take out something where they have a 2 in common, so we're going to factor that out first. Remember I told you in the beginning, we always factor out something if they have it in common before we start factoring more. So we have a 2, and that's going to give us y to the 4th minus 25. So then we split it up further since we have perfect squares in the parentheses, so we have y squared minus 5 times y squared plus 5. And since 5 is not a perfect square, we're going to leave it at 2 times y squared minus 5 times y squared plus 5, and that's our final answer. And then the next one, they have a 6 in common, so we take out the 6. That leaves us with x to the 4th minus 16. 16 is a perfect square, so we can keep going. X squared minus 4 and x squared plus 4. And then again, 4 is a perfect square, so we can keep going with the second set of parentheses, or I mean the first set of parentheses even more. So we have, I'm going to come up here, 6 times x minus 2 times x plus 2, and then we leave the last set of parentheses as x squared plus 4. Here we have factoring by grouping, so we're going to group the first two, and the second two, take out what they have in common. And again, oops. Forgot this first one has a 2 with it. And then we have 2m plus 1 as well. So then we put the first part together of each and the second set of parentheses, which is repeated. And we can further factor the first set as 25 is a perfect square. So basically whenever you see a perfect square, you have to be able to keep factoring it unless there's a plus sign in front of it. It needs to have a minus sign, like the first set of parentheses here. And then the 2m plus 1 can't be factored anymore because the 2 is not a perfect square. So that would be our final answer. Here's another one like that. We need to take out an r squared. That's going to give us r plus 6. We take out a 6 or an 11. And that's going to also give us r plus 6. So we have r squared plus 11 and r plus 6. And since 6 and 11 are not perfect squares, and they both have plus signs, we can't go any further. And here's the last one where they're asking us to solve. So we need to move everything on one side equaling 0. Then we start to factor. They have an x in common, so I'm going to take that out. Then we look at the parentheses. Since 50 is a perfect square, we can split that up. Actually, they have a 2x in common. And 50 is not a perfect square, so I was thinking ahead. Let's back up here. So we're left with this. Then we need to take out a 2x, and that'll give us perfect squares. So we have 9x squared minus 25. And 9 and 25 are both perfect squares, so we further factor that to be 3x minus 5 and 3x plus 5. So if we put all of these equal to 0, we have 2x equals 0, which would then give us x equals 0 as one answer. Then we have 3x minus 5 equals 0. So solving for x, we would have 3x equals 5 and divide by 3, or 5/3, and then the other one is just going to be negative 5/3 because the only difference is the plus sign. So this one is going to give us negative 5/3. So our three answers are 5/3, negative 5/3, and that concludes lesson 8.8.